Good afternoon, all. My name is Megha Prohit. Today, I'm going to deliver my lecture on data structure. My topic is Introduction to Data Structure, Application of Data Structure, and Classification of Data Structure. In my second slide, what is the course objective of data structure? The first one is to implement the ADT, means abstract data type, as stack, queue, and linked list. Second point is to understand the performance of the implementation of non-linear data structure. Non-linear data structure means we are talking about tree and graph. And the third point is to understand the performance of various sorting and searching algorithm. Sorting algorithm are sheep sort, merge sort, bubble sort, insertion sort, quick sort. These are the sorting algorithm. In my next slide, what is data structure? Data structure is a collection of organizing data. Here, data is a set of information. And what is information? Data with meaningful. Here, data structure is a concept of set of algorithm used to structure the information. These algorithms are implemented using high-level language like C, C++, Java, etc. Data structure example is linked list, stack, queue. Here, structure the information means store and process data in an efficient manner. In my next slide, what is the characteristics of data structure? The three characteristics of data structure is correctness, time complexity, space complexity. Here, correctness is data structure implementation should implement its interface correctly. In time complexity, the meaning of time complexity, the running time means we are talking about program. The running time or the execution time of data structure must be small as possible. Space complexity, memory usage of a data structure operations should be as little as possible. Operation means we are talking about create, insert, delete, searching, sorting, merging, splitting, and traversing, which we are using operation in data structure. In my next slide, what is the classification of data structure? Data structure are classified into two parts. First is primitive. In primitive, there is integer, character, boolean, float, and pointer. And non-primitive data structure are also divided into two parts, that is linear data structure, non-linear data structure, and linear data structure are also divided into two parts, static and dynamic. Static is array, dynamic is linked list, stack, and queue. Non-linear data structure are tree and graph. In my next slide, I will explain each and every topic. What is primitive data structure? Data structure that directly operate a upon machine instruction. These are predefined operations and property. Primitive, in short, primitive data structure are predefined operations. What is integer in that? It is a whole number. We are talking about negative, positive, and zero values. What is float? We are talking about fractional values. What is character? We are talking about character values, means A, B, C. What is Boolean? It represents true and false. What is pointer? Pointer is a variable that stores the memory address of another variable used to access and manipulate data in a memory directly. In my next slide, I will explain non-primitive data structure. Non-primitive data structure is derived from primitive, not directly operate upon machine. They are array, linked list, stack, and queue. In my next slide, I will explain each and every topic. What is array? Array is a collection of elements of same data type. Array is a collection of element of same data type. It is a static uh, data structure. Static means the memory size is fixed. It is a linear data structure and all the data is coming into contiguous form. This is the small diagrams of data structure in which the array element was given and with their array index. Array are of two types, one-dimensional array and multi-dimensional array. In next slide, I will explain linked list. Linked list is a sequence of element in which every element has linked to its next element in the sequence. Every element is called as node. Every node contains two fields, data and link. In other words, linked list is a linear data structure and it is a dynamic. Dynamic means the memory size is not fixed. In linked list, the element has called node and nodes are contain two parts. One is data part and second is next part. Data contain informations, next contain the address of next node, and there is null value and head value. From head value the linked list will start and null means there is no node at other end. In my next slide, I will explain the type of linked list. Linked lists are of two types, single linked list, double linked list, circular linked list, and circular double linked list. In next slide, I will explain stack. What is stack? Stack is a linear data structure. It is dynamic and it stores a set of elements in a particular order. Additions or deletions are made up of top of the stack. Means we can insert and delete at one end. Means top of the stack. The stack principle is last in first out. Means this is the example which was given here. There is a box in which three tennis ball was there. The first ball the first tennis ball was will delete last and the last tennis ball will delete first. Here is only one end, or we can say there is only one pointer in which insertion and deletion take place. Two operations perform on stack, that is push means we are adding the element from top of the stack, and pop we are deleting the element from top of the stack. Uh, so we can say there is only one way in which insertion and deletion take place. So complexity is very high. To sort out this problem, we use queue. Queue have two endings. Queue is a linear data structure. It has two pointers. Elements are added at one end. Elements are removed from another end. The element added first is also removed first. Means it follows FIFO rule. This is the example given here. There is a line in library who came first will delete first front of queue. Deletion will perform from front of the queue and addition perform from rear of the queue. In next slide, I will explain types of queue. Queue are divided into four parts. Simple queue, double-ended queue, circular queue and priority queue. In next slide, I will explain non-linear data structure. What is non-linear data structure? Here, data elements are not connected in a sequence manner. Means the data will come in hierarchical form. It is a non-linear data structure. The example of non-linear data structure is tree and graph. In next slide, I will explain tree. In this slide, we will talk about tree. Tree is defined as a nonlinear data structure. It is a finite set of one or more nodes such that one node is called a root node and remaining nodes partitioned into subtree of the roots. Here, A is the root node, B, C, D, E, F, G are the leaf nodes. In next slide, we will talk about graph. Graph is a represent the relationship among data item. A graph G consists of a set of V of nodes. V denotes for vertices and E of edges. Each edge is connected to node. Each node represents an item. Each edges represent the relationship between two items. This is the diagram which defined 0 to 4, which was connected to node with edges. The differentiate between tree and graph is in tree there is no cycle, no any loop. But in graph there is cycle and there is a loop. Thank you.